We're going to now look at some maximum and minimum problems, and it answers the question, why do we need calculus? Here's some applications of where we can use the calculus, and I know there are the dreaded word problems, but you just have to be really careful because all the information you need is in the problem. So let's take the first example, and this is a fence, and these are classic examples. You'll see these repeated and repeated. A fence is constructed around a rectangular area of 800 square feet, 3 sides, cost $2 per foot, and the other side costs $6 per foot. Find the dimensions of the field which will give a minimum cost. Okay, so the first thing you do is decide if you're finding a max or a min. Okay, and here it's going to be a minimum. And what are we minimizing? Max or min, and what are we maximizing or minimizing? Because that tells you the function that you need. So you have to decide, are you finding a max or a min, and then what are you finding a max or a min of? Because that's what you need to get the function for. So in this case, it's cost, minimum cost. Okay, so this is step one. Find that. Because what that means is that is the function that we will take the derivative of. Again, to find a max or a min, you take the derivative and set it equal to 0. You have to find the critical points, which means f prime equals 0. So we know we have to find the cost function here. It's going to be the cost function. So C is going to equal something. Okay, so that's step one. Step two. Well, we have a rectangular field, so let's try to draw a picture. As best as we can. We have a rectangular field, and we have the length. We have, well, let's say that's the width, because that's the short side. It really doesn't matter. The width and the length. The width and the length. Now, 3 of these sides cost $2, and one cost $6. So when you're fencing a field, we're dealing with the perimeter. So you have to realize that fence means perimeter. And a perimeter of the field is all these things added up, all the sides added up. So there's another clue right there. Every word means something, and all you're doing is translating these words into math. So fence, when you're fencing something, that means perimeter. Okay, so we have this word taken care of. We have this word taken care of. That's number 2. Find out what we can do. And another important word is rectangle. So it doesn't matter what is what. It'll all work out in the end. So now we're going to add the cost to it. Let's get our function. And we have cost is equal to $2 per foot times the number of feet, we'll say L, plus we'll say the first three are $2. Again, it doesn't matter which one you make, 2 or 6, it's going to all work out in the end. Okay, so just to add cost to it, you just multiply the cost times the length, because, all right, let's say this is $2 per foot. Well, let me just, no matter what it is, okay, just say dollars per foot times the amount of feet. The units cancel, and we get dollars. So we end up with cost that way. So we use the units. We use the units to give us dollars, and that's what cost is. Okay, now let me just clean this up a little bit. So we have 4L and we have 8Ws. We can't take the derivative of this. There's two variables, L and W. So we have to use substitution to change one to the other. Okay, now we don't have enough information here. I forgot no, yes we do. We have the area, okay? So now we come back and we look at this word, area, rectangular area of 800 square feet. So we use that to get these variables substituted. We'll call that step 4. Let's go back and make this step 4, use substitution. Okay, what's the area of a rectangle? Well, area of a rectangle is length times width. And it says that our area is 800 square feet. So we're going to use this and solve for one of the variables, doesn't matter which one, and substitute that in here, and that changes, the substitution changes to the cost equation to one variable. So this is the whole point of all these problems basically, is usually you're going to get two equations and substitute one into the other. So let's just review a little bit. First you decide if it's a max or a min, they'll tell you that. What do you want to max or minimize? That's the function that you have to come up with. So in this case we want to minimize cost, so we want the cost function. That means dollars. This means we have to come up with dollars. We draw a picture, we know it's a rectangle, and we call it L and W, or you could call it X and Y. And whenever you're dealing with a fence, that you're dealing with perimeter, so just automatically write down the perimeter of your shape. We add the cost into it. Dollars per foot times feet is dollars, so we're going to, 3 of these are $2 a square foot, or a foot, and one of them $6. Doesn't matter which one's which, don't worry about that. And then I come up with the cost equation, but that's not good enough because there's too many variables, L and W. There's 2 variables, L and W, and I can't take the derivative of that. So what I do is I use substitution to change one of the variables into the other. It doesn't matter which one. So they have to give you information in the problem, and they did. Let's go back up here to the problem. You see area, they give you fence, which is perimeter, rectangular area in the red, area of 800 square feet. Okay, so make sure you're using all the information that they give you in this problem. So, okay, let's see what we have. We have cost is 4L plus 8W But we know L is 800 over W, so we substitute that in there. That is 3200 W to the negative 1 plus 8W. I changed it like that because now, step 5, I'm going to take the derivative to find the critical point. So C prime is minus 3200 W to the negative 2 plus 8, and we set it equal to 0. So I have negative 3200 over W squared equals negative 8. W squared is 400. Take the square root, we get 20. Now you only take the positive one because we're dealing with measurements. If W is 20, then I can go back up here knowing that L is 800 over W, so it's going to be 800 over 20, which gives us 40. Okay, now don't forget this last step. You have to check and make sure that that's a min. And how do you do that? Well, you can take the second derivative test. You can use the second derivative test. So let's do the second derivative. You plug the critical point in, and you see if it's positive or negative. I don't care what that answer is. I know that's positive, so it's concave up at that critical point, so I do have a min. So make sure you go through these 6 steps every time. My rectangular area is 40 feet by 20 feet. That's my answer. Okay, let's do another one. A rectangular box is to be made out of 12 square foot of tin. It is to have a square base, and open top. Find dimensions that give the box largest volume. Okay, step 1. We want to max or min. Right, largest means max, and what do we want to maximize? The volume. So the volume is what we're going to try to find. And volume's measured in feet cubed. Each something feet cubed. Okay, so keep in mind that we need volume in one variable. This is the equation we need right here, the volume equation. That's what we want to maximize. Okay, so again, you can go back, and we're done with this sentence. We already decided that that's what we're going to do. If that helps you, that's fine. Second thing, picture. Okay, it has a square base. So let's say that's x and that's x. Square has equal sides. And the height, let's say, is h. So, and it has an open top. Square base and open top. Okay, so now we can see that our volume is x length times width times height, x times x times x, which is x squared h. Again, you see what happens is we have our equation, but there's two variables, and the two variables we need to use substitution to change to one variable. Doesn't matter which one. So we can either have all x's or all h's. It does not matter. So there has to be more information here. Okay, again, let's go back up here. Step 3 is our function. Okay, so that was step 3, picture. 4, we're going to use substitution. Let's go back up here and get our other equation. And this is it right here. A rectangular box is to be made out of 12 square feet of tin. Square feet is area. So the units, watch really carefully for your units. That tells you what the number represents. Square feet measures area. So we want the surface area of this box, and this box has 4 sides plus the bottom. We don't have a top. So the 4 sides are x by h, and the bottom is x by x. And the area of that, you have 4 sides. The area of each one is x times h plus 1 bottom, which is x squared. If it had a top, then that would be 2x squared. Okay, so this is the surface area, and we know that's 12. So we get another equation here that's equal to a number. So these word problems usually will give you 2 equations, and you substitute one in for the other. So we've used that first sentence up. Go back here. The first sentence, a rectangular box is made out of 12 square feet of tin. Square feet measures area. So the units tell you what the 12 represents. The 12 is not volume. That volume is cubic feet. Area is square feet. Okay, so the square base and top, that's for the picture. So we're done with all the information. We've used all the information that this problem has given us. So it's easier in this problem to solve for h. So we have 4xh equals 12 minus x squared. H is 12 minus x squared over 4x. Now we're going to substitute that in to the volume. Okay, and let's go back. The volume is x squared h, but we're going to put in here, this is 12 minus x squared over 4x. So when I substitute that in, it's going to be 12 minus x squared times x squared over 4x. Now one of the x's is going to cancel. So this is going to give us 3x minus 1/4 x cubed. Gives us a nice equation because the x here is going to cancel, and then I'm going to divide everything by 4. Okay, so you see what we did? Let's go back to the first problem we did. We decided what we were going to maximize or minimize. That gives us what function we're looking for. We draw a picture, and you can get the other equation if you want to, or get the function. Then we have the function we're going to take the derivative of, but usually it's in 2 variables, so you have to get another equation to substitute into it. Once you do that, you change your equation into one variable, which you can take the derivative of. So now I'm ready to take the derivative. So that's step 5. B prime is 3 minus 3/4 x squared. Find the critical point by setting it equal to 0. X squared equals 4x equals 2. Again, these are measurements, so I don't have plus or minus there. And once you get x, you can get your h, because we know h is 12 minus x squared over 4x. So h is 12 minus 4. When I substitute 2 in for x, divided by 8, h is going to be 1. So now I take the second derivative to check it. The last step is a check. 5 is the critical point. Check to see if it's a max or min. This is really important. I'll be looking for this. So we have minus 6 fourths x. When I substitute 2 back in there, it's negative. Concave down at the critical point means we have a max, and that's what we wanted. Okay, so we get the equation. We draw a picture to get an equation in two variables. We find another equation in the problem. Another sentence is going to give us another equation. And then we solve for one of the variables. It does not matter which one. Substitute it back into the problem. And check to see if we have a max or a min. So, let's see, my pages are out of order, but I will fix that. So right here, there's my equation. Then I substitute that back in. Then I check to make sure it's a max or a min. Okay, let's try. Again, I'll number these pages. Okay, next one. Find the maximum volume of a cylinder that can be inscribed in a cone of height 12 centimeters and radius 4 centimeters. Okay, so what I'm doing here is deciding what I'm doing I want to maximize the volume. So the first thing I want maximum volume. So I want V equals something to my picture. Here's my cone. I want to inscribe a cylinder and just put a cylinder inside of it. Let's make this at point 0, 0. The height is 12, the radius is 4, so this is 2. So this is the point 212. So I need the volume of a cylinder in this problem. And the volume of a cylinder is pi r squared h. Now again, this is what we want to take the derivative of, but there's two variables here, so we have to get rid of one of those variables. And to do that, we're going to call this the height and this the radius of the cylinder. So this point is RH. And we can use similar triangles to do that. Now I'm going to redraw this. Let's use this picture right here. I'm going to use similar triangles. This is R. This is 2. This is 12. And this is 12 minus H. If you look, this is H. This is the difference. This is 12 minus H because the whole thing's 12. This whole thing's 12. And this is h, so to subtract them, you get 12 minus h. So we can use similar triangles, or you can get the equation of this line. I'll show you get the same answer. Okay, so we're going to come up with similar triangles. We have r is to 2 as 12 minus h is to 12. So we have 12r equals 2 times 12 minus h, or 6r equals 12 minus h, or we have h equals 12 minus 6r. Again, it doesn't matter which one you find. Or, like I said, you could do it by finding the equation of the line. We have this line here that goes through 0, 0, and 2, 12, so the slope is 12 over 2, which is 6. And we use the point 2, 12, so we have y minus 12 equals 6 times x minus 2, so we get y is equal to 6x. This point is RH. So if x is r, we have y equals 6r. Oh, that's not h. I'm sorry, that's 12 minus h. So if I have r, then this point is 12 minus h, which is 12 minus 6r, which is what we got here. We have 6r equals 12 minus h. Okay, well, let's go back. And that step is a substitution, so I have v equals pi r squared h is my volume. I have what h is, so this is going to be pi r squared. We solved it for h. We got, like I said, I'll fix this. We're out of order here. Twelve minus 6r is h. Find the critical point. Take the derivative. Okay, factor out of r2, so that's going to be 4 minus 3r. So r is 0 or 4/3. Well, that's not going to make any sense. That means you don't have anything if your radius is 0. So r is 4/3. I'm going to check that. Actually, let me find out what h is. Since h is 12 minus 6r, I substitute that in. That's 12 minus 24/3, which is 8. So h is 4. I'm going to check that. That's my last step to make sure it's a max. My second derivative is 24 pi minus 36 pi r. And if I put 4/3 in there, then that's going to be negative, which means at the critical point it's concave down, so I have a max. So make sure you always check it. So the answer is my radius is 4/3 centimeter and my height is 4 centimeters. Okay, try another one, another cylinder. A cylindrical container is to contain, if you go through those 6 steps, these are not difficult problems, and pay attention to the units. Find the dimensions which require the least amount of material. Okay. Max or min? Well, it says least amount, so that's a min. What do I want to minimize? The amount of material. So what do you make things out of? It's what you wrap around the cylinder. That's called the surface area. Okay, so if you pay attention to these problems, usually area and volume go together 90% of the time. Surface area and volume go together, and perimeter and area go together. So surface area and volume are the 2 equations you should look for. In a 2-dimensional case, you should look for area and perimeter. Okay, this is 3 dimensions. So my surface area, well, to get the equation, I draw a picture. I have a cylinder here. And the surface area is I have 2 tops. Let's say that's my radius and that's my height. So I have 2 tops to cover plus the side, which is this right here, the side. And I have top and the bottom and top. Okay, so the 2 tops, they're circles, and the side, if you cut up the side of it like an oatmeal container or a can and lay it flat, you get a rectangle. And what's the area of a circle? Well, that's pi r squared, so all that is pi r squared, but you have 2 of them. That's the area. I'll just call this area. Okay, now this side has height h, it's h high, but this is around the circle that if you like flatten out a can, cut up the side and flatten it out, that goes around the circle, which is the circumference, which is 2 pi r. So that's going to be length times width. Now, this is what you want to take the derivative of. Again, it has 2 variables, r and h. So the top is the area of this circle is pi r squared. If I cut this circle and lay it flat, this right here is this right here. And around the circle is 2 pi r. And that's multiplied times h, because this is length times width. Okay, let's find another equation that I can substitute in. Come up here. And it's right here. A cylindrical container is to contain 1 cubic feet. That cubic feet measures volume. So there it is, right there. That's telling us that our volume equals 1. What's the volume of a cylinder? Pi r squared h. You can look these up. And I know that equals 1. So I have h equals 1 over pi r squared. And once I get my second equation, I substitute it in. And that's going to be over r divided by r squared is r to the negative 1. Okay, take the derivative, step 5. Okay, again, this is the surface area. set it equal to 0. Multiply everything by r squared to get it out of the denominator. And then take the cubed root. Okay, so there's my radius. I'm going to do that on the calculator. And that's about 0.053. Checking that. Point. 0.54. But I know h is 1 over pi r squared, so that's approximately 1 over pi 0.54 squared. Okay, what's that? Okay, so my radius and my height, approximately those. Now we need to check it. So the second derivative is going to be 4 pi plus 4r to the negative 3, 4 pi and I'm going to substitute that in, and that's going to be a positive, so it means concave up, and I have a min, and that's what I wanted. So you see, I did the same 6 steps on every one of these problems, gets me to my answer. Okay, so you can look at some of the example homework problems when you're doing these problems. Again, let's go through the 6 steps. Max or min? What do you want to take the max or min of? That's the equation that you have to come up with. Second's the picture. Third is, so this gives you an equation. Get your second equation. Solve for one of the variables in the second equation and substitute into first equation. Derivative, critical point. Take the second derivative of the critical point to see if you have a max or a min. And that's it. So you do these 6 steps, you'll get to your answer.